Hi, my name is Curtis Thorne, and I work with the X team here at Oracle. And today I will demo the OKV migration for data guard environments running on EXADB Cloud Customer. The assumption is that the audience has watched the presentation/demo on the OKV migration on EXADB Cloud Customer using REST. Said presentation and demo had more details on the versioning of various software components needed for the OKV migration, details on the commands used for the OKV onboarding process, details on automating the OKV onboarding process, the necessary steps to complete the EXADB Cloud Customer and database changes for the OKV migration, what client wallets are, what endpoints are, what secrets are, what the OKV RESTFul service utility is, etc. The purpose of this video is strictly to walk through a OKV migration on a data guard environment running on EXADB Cloud Customer. However, I do want to show the mouse note info that will be used for the demo. And also, as of today, please be aware that the data guard environment needs to be in place prior to the OKV migration on EXADB Cloud Customer. And this is something we will show in the demo. MOS note. We will use the MOS note 2828575.1 for the demo. The MOS note details all the software versions and necessary steps for the OKV migration process on EXADB Cloud Customer. The note does not specifically list a data guard setup example. However, the process is the same in that the steps are executed on both the primary and standby sites. So the OKV onboarding process, EXADB Cloud Customer, and database changes all are executed on both the primary and standby sites, and we will show this in the demo. Now we're ready for the demo. Let me pause the recording and get the demo ready. So some information about the demo environment. Both primary and standby environments are 2-node EXADB Cloud Customer rack clusters. The data guard configuration is already in place for the database that will be used for the demo. And again, I'm assuming that the audience has viewed the OKV migration using REST video. The REST video is more detailed in explaining the OKV onboarding process, automation of the OKV onboarding process, software versions, various terms like endpoints, client wallets, OKV service utilities, secrets, etc. So when such terms are mentioned throughout the demo, I'm assuming that the audience has some knowledge prior to viewing this demo. Also, I will refer back to the OKV migration using REST video in this demo, so please be aware of that. And also to make you aware, automation of the OKV onboarding process is used in this demo to save time and help prevent human error. So let's start the demo. And you see there's our primary node 1 and 2 and standby node 1 and 2. And first we check the data guard configuration. Since this is a data guard environment, make sure the configuration is whole. Configuration looks good. Now we need to check the version for the DBAS tools and the DBCS agent and the RWMS versions. We are using a 19C database, so 19.6 and up is required for the OKV migration. For DBAS tools and DBCS agent, 21.3.1.1 and up are required for the OKV migration, and you see we're good here, and we run that on all the nodes. And we check the RWMS versions. Please be aware we are using Oracle Key Vault version 21.3, so we're good to go there. And the version of RWMS is 19.14 on the primary and 19.14 on the standby side. So we're good to go. And here are the automation scripts. These scripts are taken directly from the MOS node, the OKV lead, and the OKV follow scripts. The only difference is that the OKV lead creates the wallet. The follower scripts actually use the wallet that's created in the OKV lead. This ensures that all endpoints are sharing the exact same wallet. So let me let this run, and then I'll speak a little bit more on the automation script. I speak a lot more detail on this in the OKV migration using REST video. However, the automation scripts does quite a bit of stuff here. So first off, it creates a subdirectory for the OKV RESTful service utility. The reason being, I don't, me personally, I don't store the OKV RESTful service utility bits in the same subdirectory as the OKV_home, is because they do have similar directory structures where they both have a bin and a config subdirectory. So to eliminate confusion, I just store those separately. We continued, you will see the results of the curl download of the RESTful service utility. And then you have the message of building the OKV deployment script. And the deployment script, let me pause. And I explain this more in the OKV migration using REST video as well. But the deployment script holds all the necessary commands for the OKV onboarding process. It builds the OKV_home. It builds the wallet in case of the OKV_lead. Builds the, creates the endpoint, assigns the wallet to the endpoint. And this is how we share wallets amongst the endpoints. We assign the wallets to the endpoints. And then we download and install the client endpoint software. And also you will see a message that says, hey, once we ran the script, please update the OKV wrapper script and the OKV RESTCLI.ini config file. We will go into more detail about that later. See, there's our deployment script that has the OKV onboarding process. OKV REST, and we're creating a subdirectory here for the client wallet /w. It doesn't have to necessarily be, here in this subdirectory. It may have been more easier to actually put it on a shared mount point. If you had a ZFS mount point that is shared amongst both the primary and standby sites, you can have a client wallet there where you can actually build a client wallet once and just, call it, specify the subdirectory in the OKV RESTCLI.ini config file for the client wallets on each node. And you can just use that one particular wallet for all your building other client wallets. So now we update the OKV wrapper script. The OKV wrapper script is basically where we make our REST calls to the OKV server. And the OKV RESTCLI._ directory is the subdirectory where the OKV RESTful service utility bits is located. Java_home equals the current Java version, the current JDK. Yeah, gotta make sure we get the current versions because sometimes Java is updated on once the KVM guest has been updated with this EXADB Cloud Customer software. So yeah, I make sure I check for the current JDK version. And you see the OKV REST CLI and CLI_config actually points to the OKV RESTCLI.ini config file. The OKV RESTCLI.ini config file is where we'll have the OKV server IP. And once we build the client wallet information. So reason being we do that because that helps with automation. Reason why we use the client wallet, because it helps with automation where you're not being prompted for a username and password for each RESTful service utility command. Okay. So Java. And this is done on both primary and standby sites. Okay. Now that's done, we update the OKV RESTful RESTCLI.ini config file. Initially, we only set it the OKV server IP in the OKV RESTCLI.ini config file. Reason being is because we need to communicate with the OKV server in order to create the client wallet. We're just building the client wallet so we can use automation. and we're not prompted for a username and password. And the password is hidden from the OS. That's the reason why we're using the client wallet. You can specify a username and password within the RESTful, the OKV RESTCLI.ini config file if you want. However, you exposing the password to the OS, and that's something that's kind of that's a security risk. So hence the use of the client wallet. Okay. Okay, OKV server IP. Now we're able to create the client wallet. And we use the OKV RESTful service utility to create the client wallet. You see /OKV REST/W be the subdirectory where the client wallet will reside. We're using wallet user REST _ buildout, which is a generic user that has like the create endpoint privilege. And we just use that to make our simple calls to the OKV server. And there's the client wallet. We do this on all nodes. And like I say, if you had like a ZFS mount point that can be shared amongst the primary and standby sites, you can just create one client wallet, right? And just update your OKV REST CLI.ini config file with the location of that client wallet, and you should be good to go. Okay, looks good. Now the client wallet is there. Now we update the OKV REST CLI.ini config file with the client wallet information. Excuse me. And then we have the user, which is the REST _ buildout, and the client _ wallet, which is the subdirectory where the client wallet is located, which should be the OKV REST/W. Okay, you just update the rest of the OKV REST CLI.ini config files on all the other nodes. Okay, we're good to go. Now that our client wallet information is in place in the OKV REST CLI.ini config file, now we can run a deployment script. So we will not be prompted for all the OKV RESTful commands. So now we open the deployment script, we create the OKV home, wallet, endpoint, assign the wallet to the endpoint, and download and install in the client endpoint software. Yep, create the OKV home, create the wallet, create the endpoint. Please be aware, as these scripts are taken from the MOS node, there is a hard-coded password for the endpoint client software when the command downloads and then install the client endpoint software. You can set it to like a dummy password to like make sure that just for security purposes. Then after you're done, you need to change it to the TDMS RDBMS password. For EXADB Cloud customer, the OKV Endpoint Client Software password needs to be the TDE RDBMS password for cloud tooling functionality in EXADB Cloud customer. And I mentioned this in the OKV migration using REST video. Okay, after the install, we run root.sh. Deployment script is assuming that the wallet has been created in the lead script. And when we assign the wallet, when we assign the default wallet to the endpoint, we're using the wallet that was created in the lead script. And then we run root.sh. And you see the library exists, that's fine. That lets us know that another Oracle Key Vault endpoint client software has been installed on this particular node. They're sharing, all endpoint client software share a particular library, and that's fine. I go into the various messages in the OKV using REST video. I also mentioned two messages that you might most likely see in the MOS node. Let me pause here. So when it says that the library exists, as I mentioned, it's already, that gives us an indication that an OKV endpoint client software has been installed on this particular environment already. So there's a database that's already OKV enabled on the actual node. You may, if it's a fresh install, like the first in OKV endpoint client software, you will see like creating library, setting permissions, and installation successful. If there's a newer version share library, you will see like, there's a newer version, do you want to overwrite? And you just click Y and you're good to go. Now that the endpoint client software has been installed, we need to verify communication with the OKV server and the endpoint client software. So we use the OKV util list command to do that. And we also run this on all endpoints to make sure the endpoint client software functionality, the communication between the OKV server and the endpoint client software is successful, is functioning properly. And we verify the unique IDs. Unique IDs tells us that if they're all the same, we're using the same wallet, and that's what we want. Because as I stressed in the OKV migration using REST video, all endpoints need to share the same exact wallet. And we do that within the deployment script on the assignment of the default wallet command. We assign the wallet that was in the lead script. And we'll look good to go. All the unique IDs look the same, so we look good. All right, we'll look good to go. So now we need to upload the current TDE wallets to OKV. So databases in EXADB Cloud customer has TDE enabled by default. The TDE wallets by default are stored on the ACFS mount. We need to first find those wallets by querying $encryption_wallet. And you see the subdirectory here, and that's the TDE wallets, and we need to upload those to the OKV server. So we copy those to a local subdirectory. In this example is OKV_home/TDE. It can be any subdirectory that Oracle has access to, but I like to leave the current wallets in place during the migration process. And once we migrate, then we can remove the wallets from ACFS. Okay, and we upload, then the type of key store, which is wallet, then the location of the actual wallet, which is OKV home/TDE, and -G for the wallet name. You want to make sure you get this correct. There's V for verbose. Just show a little more information. So enter source wallet password, you can hit enter because by default, EXADB Cloud Customer Databases use auto login wallets. And the Oracle Key Vault endpoint password, which is what we set when installing the endpoint client software. Ultimately, whether it's a dummy password that you hard-coded in the script, ultimately it needs to be changed to the TDE RWMS password. And that's needed, that's mandatory for cloud tooling functionality on EXADB Cloud Customer as of today. So the upload successful. Now we check the unique ID entries by using OKV util list on all the endpoints. So we run that again, make sure everything matches, everything looks good. Okay. Okay, it looks good. Okay, that looks good. Looks good. All right, so this gives us some information. It lets us know that the endpoint client software communicating with the OKV server, the functionality is there. And it lets us know that we're sharing the same wallet by the unique ID entry. So we look good. Now that's done, we continue with the database changes. So now we add the secrets and we update the initialization parameters for the database instances. Okay, there's the external key store wallet, and that's for key management, helps with key management, and we run that on all the endpoints. I'll explain that, this particular secret and well, all the secrets in the OKV migration using REST video. Now we run the auto login one for the keys that have been updated, they uploaded to the OKV server. We look good there. And now we do the changes, the initialization parameter changes, where we change the ACFS mount to the OKV_home subdirectory for the wallet root. And we change the TD_ configuration to OKV pipe file, meaning OKV being the primary key management system and file being the secondary. And you will see this after we complete the migration and bounce the database. So we bounce the database to make sure all is well. If there's an issue with the database finding the wallet, the database would not restart successfully. So this is a sanity check. We bounce the primary and standby databases, and we pause the demo since the rebooting takes some time for this particular data guard environment. And we will come back when the restart is successful. Restart is successful for the primary and standby database. That looks promising, I should say. And since it's a data guard environment, we need to check the configuration is good. Configuration looks good. Excuse me. Now that's done, now we can continue with the migrate process. First, we're going to run a query. This query checks the wallet order for the particular keys that's in the database. You will see the wallet order shows single, meaning that these keys for these PDBs have not gone through a migration process. Once the migration process is in place, once we complete that, OKV will show primary, file will show secondary key management system. Also in the Moss note, there's an actual table that we added that has the details of the particular wallet orders and what they mean, right? So this migrate actually completes the migrate process to the OKV. It actually recreates the entire database, so it may take some time. It may take more time depending on how many PDBs you have in your environment, right? So I believe in this environment, it took like a little bit over a minute. Yeah, also please be aware that once the migration process is in place, you see for the PDBs that went through the migration process will show, you know, as I mentioned, the wallet order, excuse me, will show primary for OKV and secondary for file, and you need that for the OKV migration. However, for PDBs created after the migrate process, the wallet order will show single, and that's fine, right? Because they have not gone through a migration process, but that's okay because OKV at that time is the primary key management system. Now, we ran the query. You saw that the primary and secondary did show up on the first instance, but not the second instance. So hence why we need to reboot to bounce the database. And we did that. And since it's a data guard environment, we check the configuration. Configuration looks good. Now let's run the query again. And the query needs to be ran on both primary and standby sites. And primary and secondary on both instances, and we look good to go. Now this is on the primary side, let's run it on the standby site, and it should look the exact same. Great. Now, as I mentioned before, let me pause the demo here. It shows this for PDBs that already exist prior to the OKV migration, right? So their keys have been migrated to OKV, so now it shows that, hey, the wallet order is primary or secondary. However, for PDBs created after the migration, they would show single because they haven't gone through a migration process, whether it's forward or reverse. So, and that's fine, right? So since OKV migration is the primary key management system, we should be good to go for those PDBs that are created after the OKV migration. So if you see single, don't worry about it. Now that we're done with the database changes, now we do the EXADB Cloud customer changes, which are updating the creg.ini config files. Let me pause the demo again. So normally we do not suggest making changes to the creg.ini config files because these config files actually are essential for cloud tooling functionality. However, as of today, we need to add some changes and updates to the creg files in order for the cloud tooling to be OKV aware. So we add the TD underscore OKV underscore config equals 1. That lets us know that this database is OKV enabled. The OKV underscore wallet underscore name lets us know, well, it's just more informative. It just gives more detail in backup reports. The ACFS equals nodes lets us know that the key store is not stored on the ACFS mount. The key store location is in the OKV underscore home / TDE. And we change the TD underscore wallet underscore root to the OKV underscore home. Wallet underscore home looks good. And we change the wallet underscore root to the wallet underscore root initialization parameter in the database, and that's fine. So I only made one change. Well, I made the changes on one node and then paused the demo and then made the changes on the other 3 in the background, since this is quite of a tedious process. So once we successfully make the changes on this particular node, the demo is paused, and then we just show the results of all 4 nodes. And then enable underscore wallet underscore root equals 1 is there by default. Okay, the changes has been done on all nodes. ACFS equals no, key store location, wallet root, OKV config equals 1. And you will see that on all the nodes here, yeah, for both primary and standby sites. Yep, looks good. Standby node 2, yep, looks good. Okay, and we check wallet. And this is good to do this sanity check before using the tooling to make sure all entries are proper. If the entries are not proper, the tooling will complain. So it will say, hey, probably can't find a wallet or what have you. So you want to make sure these are proper. Yep. Wallet root, OKV, wallet underscore name. Great. Wallet root, OKV, wallet underscore name. Root. Okay. All changes are successful, and that's the OKV migration process using REST on the DataGuard environment. So if you looked at the, viewed the OKV migration using REST video, you will see that the steps are similar. It's just adding the standbys in, just considering the standby site. So all the changes are is basically the same. It's just applied on the primary, both primary and standby sites. I hope this video helped. And at this point, you should be able to use the tooling. You should be able to use the backup API. You should be able to create PDBs via the tooling or UI. You should be able to clone PDBs using the tooling. Or you should be able to do all, execute all functionality as normal. Yeah, so I hope you enjoyed this demo. I hope it helped, and thank you for your time.